Okay, chapter 10 is correlation and regression. 10.1 it's a correlation, and 10.2 is regression. 10.1 is a is about finding the relation between two data sets, and for that we can find the correlation coefficient, and that's what we discussed in 10.1. And 10.2 is regression, which means if uh, if there is a correlation between two sets of the data, and if they are linearly correlated, if there is a linear regression, then how do you find that equation of line? Linear means it's a straight line, so we need to find the equation of line. That's called regression equation. Here, as you can see, that y cap equal b0 plus b1x, it's basically, it's a relation between x and y. We want to find out this relation, and that can be done if you have a set of data sets. If you have the two sets of the data, and then if you want to find out either they are correlated or not, and if they are, what is the equation of, if they are linearly correlated, then how do you find the equation of that straight line? We can use the very same technique we discussed in section 10.1. Using the TI-83 or 84 calculator, we can find out this equation. Okay, so these are some notations. And after that, this is notation, this is for sample and this is for population. It's not big deal. You have to focus on requirement, finding the equation of regression line. If we are trying to find the regression line, that means we are assuming that the data sets are correlated, and we can uh, you know they are correlated linearly, so we can find that equation of line. And for that line, that's which is called regression line, there are some requirement, the data set they have to satisfy. The one is the sample of pure data x comma y. Data is a random sample, it should be random. Visual examination of the scatter plot shows that the points approximate a straight line pattern. So when you see the scatter plot, you know um, it should be the points approximate a straight line pattern. If that is not a straight line, that means we cannot use the regression line. Outliers can have a strong effect on regression equation, so remove any outlier if they are known to be errors. So these are some requirements, and for each fixed value of x, the corresponding value of y have a normal distribution. So these are the requirement you must have to find the regression line. I'm going to show you a couple of examples where you might have to use calculator, TI-83, 84 calculator for finding the regression line. Okay. Um, yes, but one more thing I would like to, what is that? There is a, okay, these are the things you have to, when we try to, make some prediction, we have to make sure that we can only make prediction using the regression line if, those requirements are satisfied by the model we have given. So based on the what data we have given, we might have bad model, good model, or correlation and scope. So what does that mean? So I'm going to read it for you. Regression equations are often useful for predicting the values of one variable given some specific values of the other variable. When making prediction, we should consider the following. Bad model. If the regression equation does not appear to be useful for making prediction, don't use the regression equation for making prediction. For bad models, the best predicted value of a variable is simply its sample mean. Good models, that's where we can use the regression equation. Use the regression equation for prediction only if the graph of the regression line on the scatter plot confirms that the regression line fits the points reasonably well. Correlation. Use the regression equation for prediction only if the linear correlation coefficient R indicates that there is a linear correlation between the two variables. So based on the value of R, if there is a linear correlation, and it's coming from the section 10.1, so you have to go back to the section 10.1 and see for what value of R and what critical value, you know, uh, there is a correlation. Scope. Use the regression line for the prediction only if the data do not go much beyond the scope of the available sample data. meaning, you are trying to predict the value for one variable, and that variable is very, very far from the sample set you have given, then you cannot make the prediction. I'm going to give you some examples here. So let's try to look at some example. This is section 10.2. Let's start with let's say problem 3. Suppose IQ score were obtained for 20 randomly selected sets of siblings. So there is a sets of siblings, and then so number of data, there are 20 pair of data, 20 pairs of measurement yields. X bar means it's a mean of the X value, 100.15. Y bar, it's a mean of the Y value, which is 99.75. R is the correlation coefficient we have given, which is section 10.1, that is 0.954. P value is 0, and this is the regression line. You understand? This is the regression line. This regression line, we already have given the regression line. And now where X represents the IQ score of the older child, and then Y cap, that represents the IQ score for younger child. So find the best predicted value of Y cap given that the older child has an IQ of 98. So if X is 98, what is the value of Y cap? And now here is the thing, we can only use this equation if this is the what is that called, where is that, the good model. And how do you know that it is the good model? You can check with the correlation. That's why we have given this information, our p-value, and what is that, our p-value and the correlation coefficient R. Correlation coefficient is 0.954, and if you click here you can find out your critical value. So for number of data 20 and equal 20, let's go down here 20, and then significance, what is that, significance level is 0.05, so that's column 2, 20. The critical value is 0.444. So this critical value is less than the correlation coefficient 0.954. Okay, in that case, we can have this linear regression model. We can accept that from the section 10.1. That's the reason, because of this, we can use this equation of line to model that relation between X and Y. So now we can use this model to predict the value of Y cap. Remember, this Y cap is just to make sure that it's a different variable. You can also use Y instead of Y cap. That's just IQ for the younger child. And now this is the relation between the IQ level between the the older child and then younger child. So Y cap is IQ for the younger child, and X is the IQ level for the older child. So because the critical value is less than correlation coefficient, we can say that, hey, there is a strong correlation. Correlation level is significant from section 10.1. So we can use this linear relation to find the relation between X and Y. Now in this problem, basically you need to find what is Y cap when X is 98. So you just have to use the calculator just to use this value here. So I'm going to let's say so Y, okay, let me just use new slide here. Okay, so now we are sure that Y cap is equal to what is the value we have given here? It's negative 9.09 plus 1.0. Okay, let me just Y cap equal to, where is that? Okay, negative yes, negative 9.09 plus 1.09 x. So we users have to find out the Y cap when 09 plus 1.09 x is 98. 98. We can use this equation because critical value is less than the correlation coefficient. Okay, so to calculate this value you can use your calculator. So that is 1.09 times 98, 1.09 times 98 into minus 9.09, 9.09 enter. So that is the IQ for the younger child, which is 97.73. So we go here and we put 97 point, round it to the 2 decimal place, 97.73, 97.73. Check answer. Okay, so next question, the same thing, you have there is a relation between height. The data is given for the height and weight for the 100, sample size 100 randomly selected adult males. So based on this data, the height is ranged from 133 to 188 centimeter, and weight is ranged from 39 to 150 kg. Let the predictor variable x be the first variable given. The 100 pair measure, and these are the statistics we have given. That's the average. X bar is the average for x, which is x be the first variable, which is what is that, height, and y is weight. So average height for the 100 randomly selected adult male is 167.98 centimeter, and average weight is 81.39 kg. R is the correlation between these two data, which is 0.232. P value is 0.020, and this is the best fit linear regression. Okay, now find the best predicted value of y cap weight given an adult male who is 145 centimeter tall. Use a 0.10 significance level. So if your significance level is you want your answer in 90%. So as you can see here, this is we are looking for the height of 145 centimeter, and then this data covers from 133 to 188. So this is inside this range. So you can use this linear regression to to find the value of y for the given value of x. So 145 centimeter tall, what is the height? We can use this formula to calculate the height for 145 centimeter tall person, because that data is inside this range. And that's what it says, for the requirement. If you check the requirement, what is that? If you check your requirement, we went over, here. Okay, the requirement is it's not outlier, it should be inside that. Okay, here, number 4. Use the regression line for prediction only if the data do not go much beyond the scope of available sample data. So this 145 centimeter is inside the scope of the sample data, so we can use this linear regression. So now to calculate the value of y cap, just plug x equal 145 centimeter. X equal 145 centimeter. Where is that? And use your calculator the way we use. So use the calculator. So use this formula to calculate the weight for 145 centimeter tall male. You can just type this negative 109 plus parenthesis 1.08 times 145 centimeter, and if you enter it, it gives you 47.6. 47.6. So that is the weight. That is the weight for that height. 47.6. Let me just go back one more time. It's 47.6. Okay. Fantastic. So you just have to make sure that the requirement has met, to use this linear regression. In next question, we're going to find out that linear regression using the data set we have given. So our goal is to find out this linear regression. For that, you have to use calculator and you have to put this data set in your calculator. So there are the first set of the data, you can say x value. Second set of the data, you can say y value. So here it's 11, 12, 8, 14, 9, 7, 4, 13. So I'm going to just type these x values for the L1 in the L1. So 11, and then 12, and then 8, and then 14, then 9, then 7, then 4. You can plug, you can use them from lower number to the higher number as well, but I'm just putting them as is. After 4 there is a 13, after 13 there is a 10, after 10 there is a 5. I already had different data, so I'm just deleting them and putting it this new data. Okay, after 5 there is a 6. So those are the x values. And for these x values, we have different y values in the data set. So I'm going to use this new y values. For x is 11, y is 19.26. So this data in list 1 is for x value, and data in list 2 is corresponding y values for this x value. So when x is 11, the y is 19.26. So I'm going to type that 19.26. So when x is 12, the y is 19.78. When x is 8, y is 15.6. When x is 14, the y is 19.74. When x is 9, y is 17.18. 17.18. When x is 7, the y is 13.66. I'm just deleting this old data and entering the new data. Okay, when x is 4, the y is 5.74. 5.74. 5.74. When x is 13, y is 19.94. When x is where is that, 13, and after that 10, y is 18.40. 18.40. When x is 5, y is 8.74. When x is 6, the y is 11.38. Okay, so we enter all the data value as you can see here. You can double check always, for x is 11, y is 19.26, x is 12, 19.78, and everything. So now for this data set, you can go to stat here, test, and go to the same thing we did in section 10.1, linear regression, which is ABCDE linear regression test. Enter here. The x list is coming from L1, the y list is coming from L2, frequency is always 1, beta and gamma is always not equal to 0, and now just calculate. It will give you the regression line y equal a plus bx. Remember, here on the calculator they use y, but here in my lab math we use y cap, but they are same thing. Okay, here we need to find out the value of this coefficient, which is actually the value of a and b on your calculator. So what is the value of a here? It's a 2.80. So round to the 2 decimal places. So I'm going to use 2.80 for a. For the b value, let's go back here and then go down. There is a b value which is 1.4. So I'm going to use 1.4. So that's the linear regression. Check your answer. Fantastic. Okay, and now if you plot this data, you have to choose one of the the graph, and you can do it one by one, and you can just look at here. The x value is going from the lowest one is 4 up to 14. So if something is going beyond 14, that is not your graph. So look at here, this data is going after 15 as well. This is x value and this is y value, so this is not our right answer. Go check the another one more time. These values are less than, x is less than 15, which is correct, but y should be less than, look at here, the y value, the maximum y value is 19.94, right? But when x is 5, look at here, what is x? X is 5, the y value should be 8.74, but for x5 the y value is very huge, so this is not the correct one. Here x value is less than 15, y value is less than 20, so it looks kind of right, but we can double check it. For example, when x is 14, y is 19.74. When x is, this is 40, when x is 13, the y is, what is that, 19.94. Yes, when x is what is that, 12, the y is 19.78. So it looks right, so this is the right one. You can check all the pair of points, so this is not right one, so let's just check this one. Okay, well done. Now based on this graph you can see that this is not a straight line. This is not a straight line, somewhere it's comes down. It's not a straight line, so you have to choose one of the characteristic from here. Identify a characteristic of the data that is ignored by the regression line. This is a regression line, but the data characteristic should be look like this. So let's choose the options we have given. The data has a pattern that is not a straight line. Yes, that's the right one. If you go to choose other option, if you look at the other options here, for example, there is an influence point that strongly affect the graph of the regression line. No, we don't know for sure. There is no trend in the data. No, that's not right, because there is a trend. There is no characteristic of the data line that is ignored by the regression line. No, that is also not right, because this is not a straight line, and this regression line means it's a straight line, but this is not a straight line. So the data has a pattern that is not a straight line. Okay, so that's how we can use this regression. Okay,